Tetra Pak container, widely used for storing drinks and food, owes its exceptional worldwide success to this practical, light and easy-to-store packaging. In time, recycling these paper, aluminium and polyethylene multi-layered containers has evolved and become a consolidated practice. Cellulose, the main component in this packaging, is recovered by a paper mill, and the remaining substances, aluminium and polyethylene, together produce a new versatile plastic material called ecoalene. Let's see how. The paper mill receives the Tetra Pak containers from separate waste collection and begins to divide packaging components by initially dissolving the cellulose in a specifically designed pulper. The polyethylene film and aluminium are thus filtered and extracted, dried and pressed. This marks the beginning of a 5-stage process that transforms paper mill leftovers into an elegant plastic pen. The first stage consists of grinding this material down to facilitate the following washing stage. A conveyor belt then carries the mass of aluminium polyethylene flakes to a tank, to then be shaken up and continually mixed with water by rotating blades until all the matter is then transported by a rotating screw auger to the heart of this plant, the centrifuge. Here the definitive cleansing produces a double result. The plastic aluminium compound, free of impurities, is separated from the last of the cellulose that can be recycled in paper mill production. The water drains off into a microfilter tank and, once cleaned, restarts its cycle. Meanwhile, blasts of hot air blow the polyethylene and aluminium flakes through a series of tubes to dry. Finally, they are ground down further before submitting them to their first significant transformation: densification. This machine, the densifier, heats the material up to 250 degrees centigrade to obtain a homogeneous mass, which is then immediately shredded by steel blades and blasted by steam jets. This is how we obtain these irregular flake-like granulates that will be then fed into the extruder for the next stage, plasticization. This dense compound is moved from the feeder to a planetary extruder by a pneumatic transport system. This material is then subjected to 120 to 140 degrees heat to render it pliable, that is, plastic. It is then pressure injected through 7 extruder screws and then ground down to minute particles and well mixed with the aluminium components. The resulting plate-like material is compounded through another single screw extruder and die cast, to then be segmented up into cylinders by a rotating blade. As this whole process is very delicate and subject to minute variations, it is closely monitored by a computer system and qualified personnel. These small plastic cylinders are then cooled down and placed on an oscillating sifter to separate the regular-sized granulates. The ecoalene has at last been produced. Now it's the turn of Lecce Pen, a world leader in writing implements to transform this compound into a useful object. This machine, currently producing caps for ballpoint pens, will do the work. The procedure consists of heat injecting the granulates into molds. When the mold is reopened, a mechanical arm recovers the leftover framework for recycling, while the finished pen caps fall out onto a conveyor belt. Meanwhile, another machine is producing the pen bodies in the same way. The serigraphic branding, the assembly line, and the pen is ready. In this case, it is branded Tetra Pak. The just recognition for this company's persistent commitment to sustainable development and renewable resources, and which has contributed to transforming used carton packaging into the pen which is writing these words.